Hi, engineers. Welcome to our wave optics class. So this is the first lecture. We are going to cover most of the basic things related to wave optics. And here in this our wave optics, we have three parts mainly: interference, diffraction, and polarization. Today we are going to discuss about the introduction part. Especially we will focus on Huygens principle and superposition of the waves, and then we will see the introduction of interference and coherence. So in the next class, we will see interference in thin films followed by Newton rings. Like that, we will complete the total chapter. So let's start the today's class. Right. So what is wave optics? So wave optics is right. Before going to wave optics, we will see what is optics. So basically, optics is a branch of physics which we study the nature of the light and phenomena exhibited by it. So in this optics, we are going to study about the light, how it will act, how it will travel, how it will interact, and how the different phenomena like interference, diffraction, polarization, reflection, refraction, dispersion, how it will happen, and in our world, how this different type of light phenomena are exhibiting. So wave optics, we will study there. In optics, further classified into two types. One is wave optics, another one is a ray optics. So in wave optics, we will discuss the optics by treating as a light as a wave. In a ray optics, we will treat light as a ray. So at the present time, we are going to discuss about the wave optics. So in this process, we are trying to treat the light as a wave, and then we will discuss about wave optics. So when we go to the history of this wave optics, not wave optics, especially it's about light. So there is major four theories are there about the light. Started with Newton's corpusculus theory, where he proposed light is a particle and he developed the theory based on it. After some times, Huygens introduced the concept of wave and he told that light is a wave. Then after some time, Maxwell electromagnetic theory come into picture, and where it tells about light is an electromagnetic wave. Further in 1900s, when Planck introduced quantum theory, then light is treated as a photon, and further de Broglie showed that all matters in the nature has a dual nature. So now what we can treat is light is a photon and it has a dual nature. Right, now we will go for the next one. Then whenever we are going to discuss wave optics, first of all, we have to know what is wave. So wave is a disturbance in a medium that carries energy without movement of the particle. So that is the key point. So wave is nothing but a disturbance in a medium that carries energy without net movement of particles. So whenever we are discussing about the wave, we required some characteristics or properties of the waves in terms which we express the nature of the wave. That is amplitude, time period, frequency, wave, phase, intensity. So these are the terms repeatedly we will use in order to explain the wave. So in the next slide, we will see what is this. Next one is particle. A particle is a point in space which has mass occupy the space or region. These characteristics, one is mass, velocity, momentum, and energy. Now we will see the different characteristics of the waves. So when come to the waves, we have amplitude. So what is the amplitude? If we take this wave, transverse wave, and amplitude is nothing but from mean position to the maximum distance, one side it can move. That is what we call amplitude. Then phase of the wave describes the state of the motion as the wave sweeps through an element at a particular position. Right. Regarding phase, we will see later. Now we will go for the wavelength. So wavelength is nothing but the distance between two consecutive thrusts or troughs. So this may be the lambda. Between these two, this may be the lambda. we will use. Then time period of a wave. In order to complete one oscillation, how much time it will take, that's what we know, time period of wave. Then frequency of the wave. Frequency of the wave is measured in hertz and is denoted by nu, and it's measured in hertz. So simply how we can define frequency? Frequency is nothing but number of oscillations per unit time. So based on that, we can define the characteristics of the waves. So mostly amplitude, phase, wavelength, the time period, frequency of the wave. These things we use here. Then here comes the main parameter, the path difference and phase difference. So when come to the path difference, refers to the difference in the length of the path taken by the two waves. So in this picture, we can see there is a blue wave and green wave. So both are moving at a same line and same axis starting point, they are moving, and finally they reached at a particular point. So path difference means the difference in these paths, actual paths along the way we have to move and we have to calculate. Say for example, this wave moved 5 centimeters and this wave moved 6 centimeters. We are taking example. Then path difference is equal to, very simple. So the difference of these two, 5 centimeters, difference 6 centimeters. So it's a simply 1 centimeter is the path difference. Now phase difference. So phase difference reference, it's a difference in their position within their respective cycle. So one complete oscillation. So this is a cycles. It is moving green and blue. So at a particular point when they are crossing the horizon, this is what we call phase, and the difference between these two is known as phase difference. And how we can calculate the phase difference? That is simply by using this formula. Phase difference is equal to 2 pi into path difference by wavelength. So phase difference is measured in radian, whereas path difference in meters and lambda in meters. So meter will get cancelled. So we will get the phase difference in radians. That one we can convert it into angles as well. Next one is we are going to discuss about the Huygens Wave Theory. So in this Huygens Wave Theory, we will encounter two words, wavelet and wavefront. Source is nothing but from where the light is emitted. So whenever light emits, it will move in all directions. So whenever light is emitting, it is moved in all directions. So whenever it is moving, it will move like this in all directions, and it will form like curved surfaces where this one, this small curves, these what we call wavelets, and the line which connecting these, the bold blue color, is known as wavefront. Right. So what we are, the terms we have to get familiar here is, one is source, second one wavelet, third one waves. Right. The story of the picture will come later in Huygens theory. There we will discuss it. And whenever we are showing the rays, always we will draw rays as a perpendicular to it. And this is an imaginary concept. So it's make sure that most of the concepts in physics are imaginary to understand. And if our imagination is good, then it is easy to understand. Otherwise, it will give trouble to us. Right. Now, whenever we are discussing about the wavefront, we have different type of the wavefronts. There is a spherical wavefront, cylindrical wavefront, and plane wavefront. Spherical wavefront means if we have the point source is there, then we will get a spherical wavefront. Source means light source, point light source. Then cylindrical wavefront, if our source is cylindrical or line source, then we will get cylindrical wavefront. Example is tube light for this. And plane wavefront, whether it is spherical wavefront or cylindrical wavefront, And if we get after a long time, then it will convert it into plane waves. So generally the light coming from the sun can be treated as a plane wave. And even in the laboratories, if we are using the normal light sources, by using the lens, we can convert these spherical wavefront and cylindrical wavefronts into plane wavefronts. So lens is required in order to convert in the laboratory in order to get the plane wavefront. So analysis of the plane wavefront is simple. But when come to the definitions, you can see here, then Huygens principle. This is the main principle, or whatever we told previously, whenever Newton proposed particle theory, after that, after a long time, Huygens proposed 1678, this wave theory. What he proposed is, basically every point on the wavefront, is in itself the source of spherical wavelets, which spread out in forward direction at the speed of the light. The sum of these spherical wavefronts form the wavefront. So, in order to explain the light phenomena, reflection, refraction, polarization, all these phenomena, Huygens proposed light is a wave, and he tried to explain that concept based on wave theories, right? So what is the example we can take for Huygens principle? So if a pond is there, and if we throw a stone into the water, then there is a disturbance. A wave will be created and it will move on the circular rings type. That circular rings, whatever we can say, is nothing but wavefront. Gradually, the wavefronts disperse in all directions. After some time, it will get disappear. Right. Then what is this one? So previously we saw the same type of the thing. So it is a point source. Light is traveling in all directions. What we assume is light is traveling in the directions by forming wavelets. So it will form wavelets. This is the wavelet. Whenever it is moving, and here also it will form the wavelet. And the surface of the wavelets, whatever we connecting, that is nothing but the wave. So what he says is secondary wavelets amplitude is maximum in forward direction and 0 in backward direction. So this amplitude is maximum in forward direction, 0 in reverse direction. Then surface touching the secondary wavelets tangentially in the forward direction give the direction of secondary wave. So whatever the arrows here we can see, those are the directions. And what overall they are saying is simply light will travel by forming wavelets and wavefronts. And on each wavefront, each point on the wavefront will act as a secondary source. If this is a wavefront again, then the two red color dots will act as a source, and then they will form the wavelets there. So light, they will radiate in all directions. Then again it will form another wavelet and then wavefront. So like that, Huygens principle explained how the light will travel from one place to another place. So it will explain simply the motion of the light, how it is moving. Then what is this advantages we will get with it? So Huygens concept proved reflection and refraction of the light. Reflection typically takes place when mirrors are there, right? Fall on it and get reflected. Then refraction is there whenever light rays travel from one medium to another medium. Say that is a air and this is water, where one is a rarer medium, another one is a denser medium. So air is a rarer medium, water is a denser medium. So whenever light rays travel from one medium to another medium, it always change its direction. Means it will bend. It is moving into denser medium, so it will move towards the normal. So this is what we call reflection. This is what we call refraction. So this Huygens theory able to explain reflection, refraction of light. Then diffraction of the light, interference are proved by Huygens. Not only that one, diffraction of the light. That is nothing but bending of the light rays at the sharp edges. Or maybe whenever light passes through a small aperture, if that aperture width is in the order of light wavelength, then diffraction will takes place. And interference, that's nothing but the redistribution of the energy and forming bands, colored bands, or maybe bright, dark bands. So in coming classes, we will see what is mainly the diffraction and interference. So even though it is able to explain so many phenomena, but it fails to explain that it has some limits are there. It failed to explain how light will be emitted, absorbed, or polarization. So mainly it failed to explain the absorption of light and polarizations. Then it is not able to explain photoelectric effect. So basically, photoelectric effect is a very straightforward phenomena observed by Hedge long back. What it says is, if we take a photosensitive metals and light is fall on it, if we irradiate the metal with a light, the metal surface emits the electron. That's what we call photoelectric effect. So emission of the electrons from a metal surface when light is irradiated, that's what we call photoelectric effect. So this effect is observed by Hedge, and many people try to explain, scientists, based on a classical physics, but fail to explain. But finally, Albert Einstein, based on a quantum theory, able to explain that one and provided photoelectric equation. That's nothing but incident energy is equal to work function plus kinetic energy of the electron. That's it. Then a serious drawback of this theory is they are not able to withstand with the different phenomena, and this proposed a concept called ether. So ether is a medium, and they told that like in order to travel the light, it is ether should be required. Huygens assumption, but it is proved false in 20th century. Next one is what are the applications? So whenever we say advantages, sometimes we will treat it as applications, but these are the applications mostly. Little difference will be there. So we can explain a different phenomena. You can go through them. Then we will come to the superposition of the waves. So when two or more waves with the same frequency traveling in opposite direction, they may be traveling in opposite direction, they will overlap. The resultant displacement is sum of the displacement of each wave. So if two waves are there, if they are in phase, so when we see the first picture, it's a maximum is getting superimposed, then we will say it's a in phase. So whenever they are superimposed, two waves, the resultant amplitude will be algebraic sum, or we can more broad sense, we can treat it as a vector, right? So it will form maximum amplitude. That's what we call constructive phenomena. Whereas if both are in out of phase means this is the angle and this is the angle. Whenever we are measuring the angles, if we are measuring, we will measure in positive. If we are measuring the angles with respect to negative x-axis, we will, with respect to x-axis in clockwise direction, we will treat it as a minus. So whenever two waves having out of phase, then they will get superimposed. What will happen? The difference will come into picture. If they have the same frequency and amplitude, the resultant will be zero. Both will cancel each other. So like this is the principle of superposition of the wave. So whenever in a medium, when two or more waves are traveling in opposite directions, they will get overlapped, and the resultant displacement is the sum of the displacement of each wave. In the interference, we will use the term coherence. So this coherence will come here. Again, it will come in lasers. Then also we have to discuss. So what is this coherence? Coherence is very simple. Whenever we say two waves are coherent, they should have same wavelength, same amplitude, and constant phase difference. The phase difference may be zero or maybe constant phase difference. Whether they are in phase or out of phase, it doesn't matter. They should have same wavelength, same amplitude, and constant phase difference. So whenever we observe these two green waves, right? Generally, waves won't be colored. In order to understand, here we are showing the pictures with the different colors. That's the only idea. These two waves having same wavelength, same amplitude, but phase difference is 90. One is moving in positive direction, another is moving in negative direction. Even though they are in out of phase, then we will say that these two waves are incoherent. Then when come to the blue colored waves, here these waves have not same wavelength. They are totally different. There is no particular one. This is a sinusoidal wave, sine nature. This is a cos theta graph, but this is a something else. So these are not incoherent. This is what we can say. Coherence means same wavelength, same amplitude, and constant phase difference. Next one, what is the interference of light? So the modification of the intensity of the light due to superposition of two or more wavelengths is called interference. So interference means the pattern we can see at the down. Here we observe that red, black, red, black. So that red color, yellow color, green color, everything will depends on the source color, right? If we are using a monochromatic source, if it is a like sodium, yellow color strips we will get. If we are using a red color laser, then not red color laser, that's a helium neon laser, we will get strips like. What happens is, its intensity is maximum, wherever dark region is there, intensity is minimum. So basically, interference is nothing but superposition of two or more waves. There, it will form this pattern. And you may get the doubt, if all type of the waves can give interference? No. So in order to get the interference, there is some conditions we have. So the first conditions is the light source. Two light sources must emit continuous waves and have same wavelength, amplitude, and frequency. This is simply what we can say, it's a coherent. It should be coherent. It should be monochromatic. Monochromatic means single color. And next one is the separation between the source and the screen. Source means from where light is emitting, and a screen is from where we are observing. The separation between these two should be large, and the separation between the two light sources will be small. So if we required two light sources, and if we are keeping screen, then the separation between these two light sources should be same or very, very small. Then only interference will take place, and interference we told it will take two types. One is constructive interference, where we get maximum intensity, and destructive interference, where we will get minimum intensity. So for this, where we will get constructive interference and where we will get destructive interference, it is decided by the path difference. From path difference, we can get the phase difference. If the path difference is n lambda, or integral multiple of lambda, or even multiple of n by 2, then we will get the constructive interference. Destructive interference we will get whenever the path difference is 2n plus 1 into lambda by 2. Right, here we can see some examples of interference. General life we will observe. That's first one is a butterfly. Basically, we will think that it is due to its inherent nature, but it is observed that it is due to interference only we are getting the colors, blue color for this butterfly. Then soap bubbles. It is a well-known phenomena. So whenever soap bubble is there, outer layer and inner layer of this water forms these soap bubbles. So whenever the light get reflected from outer surface and inner surface, they will get superimposed, and whenever we look at the soap bubbles, they will appear different colors. Then color patches on wet roads and oil on surface of the water. So whenever we spread the oil on a water or on the generally in rainy season, we drop the oil drops on road, then we can see the spreading of these colors. This is also act as a interference phenomena example. Then anti-reflecting coatings and holograms which are used in order to identify the correct books and originality of the books. That is a one applications, but the technology is advanced and this holography is used for this designings, also virtual designings. And this is for today's class, and in the next class we will go deeper into the interference phenomena, and then we will see how we can analyze the thin film and a Newton rings experiment based on the interference. Thank you. Have a great day.